just through the last 10 years, we have been primarily a single product company. Today, the world has shifted, and the world of LifeVantage just shifted. We now have the ability to become a systems family, a systems line of products. And I know that Dr. Brian Dixon was pushing to have some testing done to see what the effect, the synergistic effect of the products working together was. We didn't know that we didn't know if we'd have it done by today, but the results came in like 2 days ago. And as Brandon mentioned, we'll probably need to have other pairs of pants in here, because it is incredible what it does when work together, when you take them together. So, if I were to be sampling this product, I wouldn't just sample one of them at a time. I would sample all three of them together, because the effect will be tremendous. Now, to tell us more about this groundbreaking new product that I believe is going to take us to the next level and change millions of lives in the process, I'd like to invite to the stage Senior Vice President of R&D, Dr. Brian Dixon, and Vice President of Marketing and Communications, Jesse Allen.
Well, thank you, Darren. It's incredible to see what you guys have accomplished in the past 10 years. It really is unbelievable. It's a pleasure to be with you today. My name is Jesse Allen. I'm the Vice President of Marketing and Communications. Stumble over communications, that's perfect. And I am so excited to share the stage today with Dr. Brian Dixon, our Senior Vice President of Research and Development.
Hey, good morning, everybody.
This tagline here, flip the switch, feel better, do more. It's a simple tagline, but is the embodiment of the PROTANDIM family of products, which is the intentional use of cutting-edge science that allows us to activate the body's natural processes to optimize health and well-being, allowing us to feel more energy, more motivation, more strength, and more cognitive ability, so that we can both participate in and excel at the activities we enjoy. It is the heart of LifeVantage. It's what sets us apart and is what gives us our competitive advantage. This morning, we're going to take a deeper dive into this competitive advantage. We're going to transform this stage into a classroom, and we're going to let Dr. Dixon teach us for the next 30 minutes. And along the way, we're going to accomplish a couple of things. One, we're going to provide an overview of the science that guides and directs the PROTANDIM family of products. Two, we're going to highlight the fundamental purpose of each product in the family. Number three, and this is what Darren was just alluding to, Dr. Dixon is going to reveal new data that he has discovered for each product in the family. And finally, we're going to give you a few more details and insight about the newest addition to the PROTANDIM family, the PROTANDIM NAD Synergizer, and all of the synergistic nature effects of the three products and how they complement one another. All of this is going to be accomplished as he educates us on cellular signaling, nutrigenomics, and the theories of aging. So are you ready? If you're ready, say yes.
Yes.
That feels good. I kind of feel like Rachel Jackson right now. All right, let's get started. So, just so you know, this presentation we're going to capture and we're going to publish it next week. But you're going to want to take notes. Get out your notebooks, sharpen up your pencils, buckle up, and get ready. Our professor is ready to teach. Dr. Dixon.
Hey, thanks so much.
I'm going to be over here on my screen.
Yeah, you can. Why don't you take 30 minutes off? Everyone ready for a little science school? Yeah? Awesome. How many people out there, scientific advisory board excluded, would be willing to trade me places to come up here and train on nutrigenomics? Any brave souls? There's one hand. All right. Oh, a few more hands. Great. But not a lot of hands went up. So what I hope to do is set a foundation for what nutrigenomics is, and hopefully an easy and understandable way so that you can also repeat and duplicate it in your business. How's that sound? Good? All right, let me start with this. Do you need a brain to be intelligent? Yes. Well, let's talk about that for just a second. When I pull the definition of intelligence, look what it says: the ability to learn and understand things. I think this is what most of us think about when someone's intelligent, right? That kid who's really good in school, book smart. But what surprised me is that second part of the definition, the ability to deal with new and difficult situations. Okay? So think about that for just a second. I'm going to show you a video, and we're going to go from just single-celled organisms into insects and then into some higher organisms. And I want you to look at what, excuse me, if you can go back and play that, that was my fault. But if you will think about all the behavior that's going on in these different organisms, this single cell doesn't have a brain. Does it need a brain to be intelligent? How is it bouncing around that microscope slide, interacting with its environment, looking for food? Doesn't have a brain. How about this amoeba spreading out, looking for food? Here's an immune attack on a parasite. How do our immune cells know how to do this? Here are yeast growing, dividing. How do they know how to do it? Think about a plant. If I put a seed in the ground, how do those roots know to grow down and those leaves know to grow up? Plants can even respond to touch. Did you know that? What about sunflowers? How do they know to follow the sun through the course of the day, and in the night they reset themselves so they're facing the sun when the sun rises? We've all seen bananas rot on our countertops. This is a very interesting example. Plants clearly don't have a brain, but here they are feeding on an organism that has a primitive brain. How are the plants outsmarting those organisms? It's incredible. Ants, they follow these trails. How do they know? These ants are actually farming those leaves to grow a fungus that feeds the colony. Amazing. Ants are farmers. Forgive me if anyone's squeamish with spiders, but spiders spin a brand new web every single morning. It's where they catch food, it's where they store their food, and it's even what they call their homes. Okay? Probably an Australian spider. Sea stars. You think about them just sitting on the seafloor, not moving around, doing anything. But look, they're interacting. This octopus, it's going to instantly change color when it comes across a threat, and then mimic a fish and swim away. How do they know how to do this? Amazing. Honeybees, an incredibly complex behavior. So one of the sisters from the hive has been out foraging for food. She comes back to the hive, and through this little dance, communicates to her sisters where food's located, exactly what it is, and how far to fly. It's amazing. How do they know how to do this? In fact, they're changing a gravitational compass into a solar compass. How do they know how to do this? The chameleon is thinking about changing colors. How do fish know how to swim in schools? Why do baby ducks follow their mother? Why do dogs fetch? Are they thinking about this? Cats hate water, but did you know they're really good swimmers? Why do most mammals, within minutes if not hours after they're born, why are they able to stand up and walk around? How do they know how to do this? Here's some human examples. It's self-preservation. They're not thinking, this hockey goalie save, and watch this save by a soccer goalie. This is slow motion. That goalie does not have time to think about making that save. He's just reacting to the play. Right? And I always laugh when people tell me they can't swim. Because we're born with this inherent ability to make these primitive swimming moves, and we know to hold our breath underwater. Okay? So what is going on in all of these cases? From the single cell up to the human, is intelligence sitting on top of our shoulders, or is there something else going on? So do you actually need a brain to have this intelligent behavior? No. Think about you guys, just sitting here. Are you thinking about... Are you thinking about the blood going through your veins? Are you thinking about all those nerve impulses? Are you thinking about your breathing? Are you thinking about digesting the breakfast that you had this morning? If you were fortunate enough to get a workout in, are you thinking about your body repairing those muscles and building up those bones? Or is it just happening? It's just happening. I'm going to show you one more example, okay? I love to use the skin for an analogy, right? The skin is an organ, but I love it because we can see it. And forgive me if anybody's squeamish with blood. I'm going to show a video of a woman who cut her finger pretty badly preparing dinner. A pretty bad cut. But then, what she did was went on and photographed her finger every couple of days to look at that healing process. What most of us don't appreciate is the wound healing process is an incredibly organized process. It starts with the immune system to take away all that damaged tissue, and then your skin cells have to grow and divide to ultimately make your finger as good as new. It's amazing. Was she sitting there thinking, heal, 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 or was it just happening? Amazing, right? So what did everything have in common? What's the word that you can use to lump all of these behaviors together? Do you call it luck? Skill? Adaptation? Maybe we're getting a little warmer? If you were to ask me, I'd call it this. Instinct. They just know how to do it. Right? Think about instinct for a second. We can feel when someone walks up behind us, right? We can feel when somebody's staring at us from across the room. Right? This instinct. So if we have this instinct and these other organisms have this instinct, where would it live in the cell? Here. It lives in your DNA and your genes. And just to clarify a little bit of terminology, if I were to reach into the nucleus of one of your cells, pull out that DNA, and stretch it out here on stage, it would be between 2 to 3 meters long, right? Or 6 to 9 feet. It's massive, all coiled back up on itself microscopically and put back inside the cell. A gene is just a small piece of that DNA. Okay? We have somewhere between 20,000 to 35,000 different genes inside of every one of our nuclei. Amazing. Let me ask you a question. Is DNA active or passive? How many people say active? How many people say passive? You might be surprised by my answer, but I say it's passive. Okay? DNA's job is to do nothing more than store information. It's just sitting there. I'll give you a couple examples. I used to work in a genetics laboratory. One of the projects in that research laboratory was working with archaeologists. So the researcher would go to these archaeological sites and bring back to the lab stone tools. Now, if you've ever seen a stone tool or a weapon, they're incredibly smooth and incredibly sharp, right? But when they pass through tissue, whether it's human tissue or animal tissue, tiny microscopic amounts of DNA make it into these micro cracks that are in these tools. This researcher could bring those tools back to the laboratory, carefully rinse them off, collect the DNA, amplify it up, and sequence it, And they could tell what these civilizations that are tens of thousands of years old were hunting and who they were fighting. DNA is an incredibly stable molecule. IT professionals are using DNA to store data. Because DNA is so stable, we can store information in DNA longer than any digital format we can come up with. DNA is a passive molecule that's just sitting there storing information. A lot like this blueprint. Is there a lot of information here? A ton of information. It's overwhelming. But can that piece of paper actually build the house? No. A piece of paper can't swing a hammer, can't pour concrete. It takes a very skilled worker to read that blueprint and then direct a very skilled worker class, right? A whole bunch of people have to build that house. Okay, so if DNA is like a blueprint, then who are the workers inside of that cell? Who are the workers? I say it's proteins or enzymes. So I think of enzymes as being like these little machines inside of the cell that are making everything the cell and our bodies need to function optimally. Okay? So if the proteins and the enzymes are doing the work, who's the boss? Who's directing the workers? It's cellular signaling. And what I should say more specifically is it's coordinated cellular signaling. And it's nothing more than A telling B, telling C, telling D to make something happen inside of the cell. And then everyone goes to work. So we're going to spend a little while on this one. I'm kidding. But I put this up here to illustrate just the complexity of cellular signaling. So when I was doing my molecular biology research, I would use exactly this chart to try to figure out how the signal is getting through the cell. So there'd be some input. It could be a chemical, a pharmaceutical, a drug, a nutrient, and then we want to make something happen. As a molecular biologist, we want to figure out exactly the way that signal is getting through the cell. But as complex as that is, it's nothing more than A telling B, telling C, telling D, and then what? Something happens. So what initiates this cellular signaling? What kicks it all off? Called receptors. And you can think of these as little sensing proteins that are sitting on the outside of the cell, or maybe even floating around inside of the cell. They are the sensing molecules that initiate cellular signaling. Receptors work a lot like a lock and a key. Right? If I pull out the key to my house, is it going to open your front door? No. Just like your key isn't going to open my front door. The key is like a signaling molecule. There's a lot of specificity. And then through some complex chemistry, they fit like a lock and key. You unlock the lock, you initiate the receptor, and then you get that whole chain of events that occurs. And you can even see at the top of this chart, it says receptor. You can also see the signaling molecules binding to that receptor. And then that chain of events is initiated. Okay? Another analogy that I like is that cell signaling is like a chain of dominoes. Okay? And if you've ever seen these massive shows of people knocking over dominoes, they always like to have a big grand finale. Right? So there's an input with a signaling molecule, and then something happens. Okay? So I'm going to show another video here, but can you all see the different aspects of cell signaling here? What would the signaling molecule be? finger. Where would the receptor be? The first domino. Then you get the chain of events, and then something's going to happen. So what? A tiny little input. Bing. One domino is going to knock over 2 dominoes. And then all of those dominoes fall, and then bang, something massive happens. Okay? This is the power of cellular signaling. We can get massive effects from tiny little inputs. And I can give you 2 examples you're probably familiar with. Think about a bodybuilder. They can ingest small amounts of testosterone, and they can put on massive amounts of muscle and completely remodel their physiology. Think about women, birth control pills. We can take this tiny little pill or a patch and completely remodel a woman's reproductive physiology. Tiny input can have massive consequences. This is the power of cellular signaling. And to put it another way, here's another chain of dominoes. That first domino that he's going to have to knock over with a pair of tweezers just weighs 1 or 2 grams or a fraction of an ounce. That last domino is over 100 pounds or about 50 kilos. Okay? So you can get this signal amplification through self-signaling pathways. It's amazing. This is the power of cellular signaling. This is what's coordinating cellular function. So then, what would the purpose of these cell pathways be? Well, do you remember that second definition of intelligence? To react and respond to their environment. Their internal environment, their external environment, and maybe what's going on somewhere else in our bodies. Okay? So is that not a form of intelligence? This is where that instinct or that intelligence is living. And it literally doesn't matter which cell signaling pathway I put up here, they're all working in the same way. As complex as they are all working in the same way. So now, what about nutrigenomics? For me, the seminal work is here. Have you ever heard that chocolate, and that nasty dark chocolate, is actually really good for your cardiovascular health? Yeah. But why is that? And this was exactly the question that these researchers wanted to answer. Why is chocolate so healthy for us? So these researchers go in, they pull out the different compounds from chocolate, and they start to investigate. But to their surprise, they found 2 things. One, these compounds aren't actually that abundant in chocolate. So they're present in low concentrations. Moreover, they found that when they give these compounds to people, they are very poorly absorbed. So if there's not a lot of them to begin with, they're not bioavailable, how can they be having such great effects? This is what they sought to answer. They found that one of these compounds from chocolate can't make it into the cell. So it's not even getting in where it can do any good. But what they found through a series of experiments is that it's actually binding a receptor and doing what? Activating cellular signaling pathways. Then they go on and do the molecular biology, they figure out how that signal's going through the cell, and they're even able to identify the proteins that needed to be turned on so that we can experience those cardiovascular health benefits when we indulge in some dark chocolate. Okay? This is the whole concept of nutrigenomics. Using nutrients to activate cell signaling pathways to turn on health-promoting genes. Simple, right? So now you can trade me spots and finish the lecture then. How's that? So how does LifeVantage then apply these principles to its product line? How are we utilizing nutrigenomics in making you as healthy as possible? The easiest way to talk about it is by couching it in the theories of aging. Now there are many, many different theories of aging out there, And you might ask yourself, well, why is that? Well, researchers have been looking for years and years and years to try to find the one thing that's responsible for the aging process. But they weren't able to find it. So then they add a new theory and a new theory. They still haven't found the one thing that's responsible for why we get old. So what's probably going on is there's an additive effect with all of these different theories. A little bit of deleterious effects from one, from another, and you get these additive effects. So our approach has been to tackle the most well-known, the most researched, and then how can we combat them? Okay? So the three we're going to talk about today are the oxidative stress theory of aging, the mitochondrial theory of aging, and the newest to the PROTANDIM family, the sirtuin theory of aging. So here's the pathway for NRF2. You've all heard of NRF2?
Yes.
Once or twice? So look, NRF2 gets released, goes into the nucleus, and flips these switches for these protective and survival genes. Okay? So how are we utilizing this knowledge in our product line? And in this case, specifically, PROTANDIM NRF2 Synergizer. It's simple, right? Think about signaling molecule or input. It's nothing more than the ingredient deck. What's the switch? I'll give you a hint. It's in the name of every product. Okay? In this case, it's the NRF2 pathway. And then we get all of those benefits that we experience. So both Darren and Jesse have talked about some new data that we got back. Okay? So we were asking the experimental question, if PROTANDIM NRF2 Synergizer is working as advertised, can we measure it? So NRF2 is going to go into the nucleus, and can you see it's going to turn on genes? We looked at two of those genes, and the names don't really matter, but it's NQO1 and heme oxygenase, right? Two of these pro-survival genes that are regulated by NRF2. So if PROTANDIM NRF2 Synergizer is working as advertised, we should see those genes turned on, right? Well, look what we found. In just 24 hours, we saw a 40% increase in NQO1 and a 51% increase in heme oxygenase. The products are working as advertised. How about the second theory of aging, the mitochondrial theory of aging? If you're not familiar with what the mitochondria are, they are the powerhouse of the cell. They are literally generating all of the energy that we need to function every second of every day. They are so important to our health and well-being that if I were to take somebody, snap my fingers, and shut off their mitochondrial function, they would be dead in a matter of seconds. That's how much energy we're consuming. The most toxic compounds on Earth work by shutting down mitochondrial function. They are essential for our long-term survival. So what's the mitochondrial theory of aging? The mitochondrial theory of aging states that as these mitochondria are working, and even the healthiest of mitochondria are producing a little bit of oxidants and free radicals. So those oxidants and free radicals are working back on the mitochondria, causing damage, and you start to get this vicious downward spiral. The mitochondria are also particularly susceptible to other insults and oxidative stress and free radicals. So you can see it just continues to viciously spiral downhill. As we age, the mitochondria don't work as efficiently, and they produce even more free radicals and antioxidants. So we were asking the questions, were there things we could do to promote mitochondrial health? The gene that's been shown to regulate mitochondrial health and mitochondrial turnover is called what? NRF1, the name of the product. So again, if we come back to our framework, the signaling molecules or the input are the ingredients. What's the switch? The NRF1 pathway. And then all of those health benefits related to mitochondrial health. So again, if we come back to our scientific framework, and PROTANDIM NRF1 Synergizer is activating the NRF1 protein, we should be able to measure the genes that are regulated by NRF1. So interestingly, NRF1 actually regulates itself, so when it's active, it turns on more of itself, and then another important protein called PGC1 alpha that's been shown to help with mitochondrial turnover. Okay, so we're moving the bad ones and putting good ones back in their place. Okay. What did we find? We found that PROTANDIM NRF1 Synergizer could increase the NRF1 gene by 65% and increase PGC1 alpha by 71% in just 24 hours. The products are working as advertised. Let's talk about this latest theory of aging to life advantage, the sirtuin theory of aging. Hold your hats, here we go. There's a family of proteins called the sirtuins. The sirtuins are so interesting because when they're activated, we get a number of health benefits that result. So up on the screen, I've really simplified this, but one of those is called autophagy. This is known as cellular cleanup. So you can literally think of this as being a little vacuum cleaner moving through the cell that's picking up all the garbage that accumulates over time and as we age. And then we talk about balancing a healthy inflammatory response, and you get this whole host of health benefits that ultimately result in healthy longevity. The problem is, sirtuin activity declines by 60% as we age. So what can we do? We looked at sirtuins, and we asked the question, what's the thing that's been shown in the scientific literature to best activate sirtuin activity? It's a phenomenon called caloric restriction. Now this isn't just a little diet. We're talking about drastically reducing the number of calories that you and I would eat every day. We would only be able to eat about 700 to 800 calories every single day if we want to activate sirtuin protein. Does anyone want to eat 750 calories the rest of their life? No, it's a miserable existence, okay? So caloric restriction activates it. More research went on and they found something very interesting. There was a molecule called NAD that is required for that sirtuin activation. Okay? So under caloric restriction, what's been shown in terms of increasing sirtuin activity? There's a 94% increase in the activity of these sirtuin proteins. If we want to look at NAD and activate sirtuins through NAD, we also have to look at the NAD biosynthetic pathway. Forgive me, this one is complicated. But what I want you to take away is on your left side, your body can make NAD from scratch, okay? On the right side, your body can make NAD by recycling the NAD that's been consumed in various enzymatic reactions. So two ways to make NAD, from scratch or through recycling. So we asked the question, could we activate the NAD biosynthetic pathway nutrigenomically? Again, it's nothing more than utilizing the signaling molecules for the input, the ingredients in the product, the switch, the NAD pathway, and then all of the health benefits that we experience. So we come back, well, trust me, it gets way, way better. You're clapping already. So if we come back and we look at this NAD biosynthetic pathway, there's two enzymes that are the most important to make NAD, recycle NAD. Okay? If we go into the laboratory and we measure the upregulation of these genes through these nutrigenomic interventions, what did we find? We see a 12% increase in the expression of these genes. But remember, it's sirtuin activity that we're trying to target. So what did we see? Remember, caloric restriction increases by 94%. What did we find? 100%. 100% activation. Amazing. And just for fun, we were curious about the competition. The competition is utilizing a different approach. They're not using nutrigenomics. They're trying to make it from scratch. Okay? What did they show? Only a 2% increase in sirtuin activity. 50 times lower than PROTANDIM NAD Synergizer. And thus, you'll experience the improved mental focus and concentration, supporting a positive mood and motivation, boosting mental and physical energy, supporting the body's healthy inflammation response, maintaining cholesterol levels already in the healthy range, and overall cardiovascular health. To name a few. Amazing. This nutrigenomic approach to nutrition works, and we can show this in the laboratory. I'll be back in a second.